Hello dear friends, welcome to this video in our YouTube channel. In this video friends, we shall be looking at the question 2 of the Northwest Advanced Level Physics paper 2. We shall be looking at the question 2 of it, which is based on uniform circular motion. So friends, watch the entire video from start to finish so that you're going to have a clear understanding about the concept. So friends, for a quick reminder, if you're new to this channel, don't forget to subscribe to the channel and turn on your bell icon to get notified each time we upload new videos, guys. And please give the video a like, because that does motivate me enough. That actually tells me that you found the content so useful, and I'm going to keep doing so for you guys once you indicate to me by liking the video that it was so helpful. Great. So friends, let's dive straight into our video today. The question is that in figure 1, that figure 1 shows a mass M attached to one end of a string of length 1.1 meters and wheeled in a horizontal circle. This is the diagram that the question has provided. Then they said calculate A, the tension in the string, B, the period of revolution of the string, C, the tangential velocity of the bob. So guys, I'm sure the question made an error here. Here was supposed to be the period of revolution of the bob, okay, not the string. All right. So friends, let's start. Now, the first thing that we want to do is that we want to observe all the forces that are acting on this our bulb. Okay, we want to observe all the forces. So let's see if we can draw some sort of free body diagram to see all the forces acting. So since the bulb is a mass, therefore means it has a weight, right, which can call that weight mg. And in fact guys, it has a tension. The tension in this string has some tension. Since the bulb is going to exert some weight downward, therefore means there's going to be some tension acting in the string. And since the string is being inclined at this angle 30 degrees, that therefore means that the tension is going to have two components. We have the vertical component and the horizontal components. And guys, since the bulb neither goes away from its circular path nor descends beyond this horizontal circle, that is to tell you that the forces on both sides, that is the horizontal forces, are being balanced, as well as the vertical forces. Great. So we have the weight of the bulb. Then guys, we have this angle 30 degrees. Here is also going to be, here we're going to have the component of this tension, okay, the component of this tension. But meanwhile guys, this angle here also has to be 30 degrees. The angle in which this component makes with the string has to be the same 30 degrees, since you can see that this is Z angle form here, right? So this has to be 30 degrees. Then friends, the components upward, if you resolve the tension vertically, we are going to have this to be T cos 30. Then friends, the components that counteracts the centripetal force, we are going to have it to be F sine 30 degrees. Then guys, the force that prevents this our bulb from leaving its horizontal path is the centripetal force, which is a center seeking force. Great. So we can abbreviate that as FC. Great. All right. So guys, I think we've had everything right. I think we now have everything it takes now to answer this our problem. All we need to do now is just to apply our physics and some concepts to finish this. Great. Okay friends, let's see. Friends, if we resolve the forces horizontally and vertically, we are definitely going to have, if we resolve the forces vertically, guys, we are definitely going to be seeing this force, that's F cos 30, right, being balanced by what? The weight mg. That therefore means we are going to have our F cos 30 degrees, which is the same as what? Mg. We can call this our equation 1. Great. Then friends, resolving it horizontally, we are going to have the centripetal force, right, Fc, which is being balanced by what, guys? By F sine 30, right? So we are going to have our F sine 30 degrees, which is equal to our Fc in this case, guys, is what? The centripetal force, right? And it is given as mr omega squared. Okay, this is what this centripetal force is given as. Great. Since this our bulb is going to move in a horizontal circle, right, means there is that force that prevents this our bulb from leaving its circular path. That force is called the centripetal force. Note friends, please note, the centripetal force is not a kind of force like for instance, just assume that an exam, in an exam, they might ask to name two types of forces. Guys, don't ever mention centripetal force. Okay, don't ever. The centripetal force is provided by another force, so it is not an independent force that can exist on its own. Okay, it is provided by a different force, and it is a center seeking force. Great. So we can call this our equation 2. Great. So guys, keep in mind that we just brought in m, right, and omega. So it is so good for us to define what these two guys are talking about, but we know m already, so we might not define m, but let's just define it. So we can tell them that where m is equal to 2 kilogram and omega is the angular velocity. Great. That's what we have. So friends, let's now start answering the question, because we have not scored any marks yet. Okay, we haven't started scoring the marks. This question was designated for 6 marks, so let's start scoring the marks now, friends. We can tell that from equation 1, comma, that therefore implies this is equation 1, right? That therefore implies we have F cos theta equal to what? Mg. Keep in mind that the equation wants us to get the tension. The tension in this case is F. No need to tell them that F is the tension, since we've indicated here on the diagram already. Great. So we have F cos 30 equal to Mg. If we divide H by cos 30, right, we are going to have our F to be the same like Mg over cos 30. We plug in everything, guys. Our M is simply 2.0 kilograms. Our G is 9.81 meters per second squared. Then we have cos 30. So friends, if we simplify this, our results will and put the answer and respect the decimal places, because the question gave the length with 1.1. They gave the mass with 2.0. They were not if they could just say M is 2 kilograms and they ended there. Okay, but here they've said 2.0. So you have to give all your answers to 2 decimal places. Wait. So in this case, guys, we are going to have our F to 2 decimal place to be 22.7 newtons. That's that is to 1 decimal place. Sorry, to 1 decimal place. All right, that's how we can answer the first part, guys. Then now the B part, guys, they want us to get the period of revolution of the string. All right, so friends, to get the period of revolution, we have to use our equation 2. Okay, so guys, from equation 2, we know that F sine 30 is the same like what, guys? Mr omega squared. Now friends, if we can get the value of omega, right, it therefore means we've gotten the period already. Okay, great. Because the period is given as what, guys? 2 pi over omega, right? So let's get an expression of omega and substitute and make t the subject and solve. Great. So friends, we have our F sine 30 to be same like what? Mr omega squared, right? Good. But we know that our t is the same like what, guys? 2 pi over omega, right? We define omega already, so there's no need for us to tell them what omega is, because we defined already. That therefore implies, guys, we must have to tell them now what t is. So we can tell them that our t in this case, what, guys, is the period of revolution of the bulb. Great. That therefore implies, guys, that therefore implies if we make omega the subject here, our omega simply becomes 2 pi over t. Now, guys, if we substitute this omega equal to 2 pi over t in equation 2, we are therefore going to be having F sine 30 equal to Mr. Omega is 2 pi over t, so we have 2 pi over t squared. That therefore implies, guys, if we make t squared the subject, we're going to have our t squared to be the same like what, guys? 4 pi squared Mr over F sine 30. Friends, you notice that we have 4 pi squared is a constant. We have M, right? We have F. We have sine 30 is a constant. We don't have R. So we have to get an expression for R. Okay, great. But friends, can you see that there is some right angle triangle that is being created here? Yeah, there's some right angle triangle, right? So let's take that right angle triangle out. This is it. Okay, where the angle is at this point, the length of the hypotenuse of this our right angle triangle is simply the length, right? The length is 1.1, and this is going to be our R. This is the angle 30 degrees. This is the angle that is being indicated here. Our R in this case is what, guys? We have here to be R. So friends, we need to get an expression for R. We know that sine of 30 degrees is the same like what, guys? Opposite of our hypotenuse, right? That therefore means the opposite in this case, which is R, has to be same like what, guys? Hypotenuse times the sine of theta. Hypotenuse is 1.1, so this is our R not turns out to be. So we are going to have our t squared to be the same like 4 pi squared m into R is what? 1.1 sine 30 over f sine 30. So sine 30 and sine 30, they can cancel, guys. We know the value of f, right? We calculated it here already. But friends, keep in mind that this 22.7 is an approximate answer, okay? It is highly approximated to 1 decimal place. We are not going to use this answer that's been approximated. We are going to use the 4 decimal place answer, okay? Good. So friends, if we take the square root on both sides and plug in our values, we are going to have our tension t to be same like 2 pi. Because if we square 4 pi square, we're going to have 2 pi comes outside. Then we have our m, which is 2.0. Sine 30 will cancel sine 30 here, so we have 1.1 all over. This our answer gives us 22.6552 to 4 decimal place. So friends, if we simplify this way, we are going to have our tension to 1 decimal place to be same like 2.0 seconds. Wait, I'm at the period, sorry guys, the period. We're going to have the period to be same like 2.0 seconds. That is to 1 decimal place, sorry. All right. Now friends, the last part of the equation wants us to get the tangential velocity of the bulb. All right. So friends, to get the tangential velocity of the bulb, we simply have to know that from V equal to omega r, we have to tell them what V is, guys. Where V is a tangential velocity of the bulb, it therefore means that, guys, we know that our omega in this case is what, guys? Our omega is what? 2 pi over t, right? Good. So this our formula now tells us to be V equal to, we have 2 pi over t times r. Good. So if you substitute everything, guys, we are going to have our V to be the same like 2 pi is a constant. We have our r, we had it here to what? 1.1 sine 30, right? So we have 1.1 sine 30 divided by our t is what, guys? Keep in mind that our t, we are not going to plug in 2.0 seconds because it's an approximate answer. So we are going to go back to our calculator and take the answer we have to 4 decimal place, okay? So we have 1.9580. That's 4 decimal place. So if we punch and simplify and put our answer to 1 decimal place, we are going to have the tangential velocity v to be same like 1.8 meters per second. Great. So guys, that's how we can answer this question. That's it. So friends, I want you guys to take note, okay? Because this is a case for an object that revolves in that creates a conical pendulum, okay? This is it. And guys, in such a case, now the period of revolution of a simple pendulum that we all know is given as what? T equal to 2 pi square root of L over G, right? Great. But in this case, you can see that the length that we are interested in this case is not just this length, okay? Because this length, because this guy makes an angle with the vertical, right? Good. So in this case now, the length in which we are interested in now is this vertical length, and this vertical length, as you can see, guys, is the adjacent of this angle, right? So in such a case, guys, our period t has to be given as 2 pi times the square root of L cos theta, okay, where theta is the angle in which the string makes with the vertical, with the downward vertical specifically. Great. So that's it. So we have L cos theta over G, no longer L over G again. So you could, if you use just this formula and you plug everything here, you're going to have this same answer, okay? But friends, keep in mind that this is physics. You have to be telling them the physics of the problem as you progress, okay? So it is not so advisable to use this formula unless it is for an MCQ question. That's when you can just apply this formula and you simply get your answer. But in paper 2, guys, I advise you to go through this step, okay? Go through this step. All right, so friends, congratulations to all those who have been able to watch the entire video, guys. Congrats to all of you, and I hope you found the concept so useful and engaging. If you found it useful, guys, I want you to hit that subscribe button right now and press the notification icon so you're going to get notified each time we have new videos. Great. And guys, feel free to reach me out. I'm going to leave a link to my WhatsApp contact in the description for your convenience. Thank you so much, and have a blessed day.